Hi, my name is Bruce Blumberg, and I'm a professor of developmental and cell biology, pharmaceutical sciences, and biomedical engineering at the University of California, Irvine. Earlier in this course, you learned about EDCs, endocrine-disrupting chemicals, and their effects on the environment and on humans. In this lesson, we're going to discuss one class of EDCs, obesogens. We'll start by asking the question, can the industrial chemicals we produce be a factor in the obesity epidemic we are seeing in modern societies around the world? Obesity, as you know, is a big problem in the world today. Although it's a global phenomenon, obesity is particularly troubling in the United States, where approximately 34% of adults are clinically obese. That is, they have a body mass index, or BMI, greater than 30. Even more troubling is the news that about 68% of American adults are overweight with a BMI greater than 25. This is part of a long and troubling trend. The number of obese people in the United States has been steadily climbing, as you can see here. These data represent the time frame from 1994 through 2008. You can see from these maps that come from the Centers for Disease Control, as we go from states colored in light blue to dark blue to tan to orange and red, that as a nation, the United States is getting fatter. There is no other way to put it. Today, there is only one state, Colorado, where less than 20% of the population is overweight. Approximately 104 million people in the U.S. are clinically obese, and 2/3 of all Americans are overweight. That is costly because obesity is very expensive at many levels. Not only does it negatively affect our health when we weigh more than we should, but the situation financially stresses the healthcare system. It's hard to say by how much precisely, but when we added up the cost of treating diseases that result from obesity in 2009, the price tag was estimated at $147 billion. These are extremely dangerous diseases. In 2007, they included adult-onset diabetes, 23.6 million people, coronary artery disease, 17.6 million people, high blood pressure, 73.6 million people, and strokes, 6.4 million people. And these don't begin to include the number of people at risk for certain types of cancer that are associated with obesity. What are the root causes of all this expense? Obesity is associated with something called metabolic syndrome, which is a precursor to type 2 diabetes and cardiovascular disease. People with metabolic syndrome have central abdominal obesity, that is, a big belly as opposed to a big bottom. A hallmark of metabolic syndrome is a suite of conditions including high triglycerides, high bad or LDL cholesterol, low good or HDL cholesterol, high blood pressure, insulin resistance, and the tendency to develop blood clots. These are all risk factors for diabetes, heart disease, atherosclerosis, and strokes, serious diseases that require an enormous amount of costly health care. The big question is, what is making us fat? If you ask your doctor, he or she will typically say, lay off the junk food, you eat too much, get some more exercise. I call that couch potato syndrome, too much food, too little exercise, or more formally, positive energy balance. And that couch potato syndrome may certainly be a major cause of obesity. But in this lesson, we are going to argue that the problem is much more complicated. If it were as simple as balancing our caloric checkbook to make energy burned equal calories consumed, very few people would be seriously overweight, and the obesity epidemic we are facing would not be as widespread. In addition to overeating and not getting enough exercise, there are other factors that may be at work here. Stress, for example, is also associated with obesity. Almost everyone has had the experience of being stressed and then eating our emotions. Usually the results aren't good. Another theory is that we've evolved a set of so-called thrifty genes that help us to use calories very efficiently and as a result enable us to efficiently store excess calories as fat. Some believe that these genes emerged during our hunter-gatherer days when food was scarce. During that phase of our evolution, having these sorts of genes would have provided a big advantage, since those who could efficiently store excess calories easily would tend to survive famine better than others. But now that food, and very high-calorie food at that, is everywhere and available on demand, these genes are no advantage. Far from it. There are also genetic reasons for obesity. Changes in a number of genes have been associated with obesity in humans, but it is important to note that there is no single genetic mutation that can be associated with obesity. Other forces can also have an effect on our body weight even before we're born. Poor prenatal nutrition is known to have a crucial impact on whether an embryo will eventually develop into an adult who struggles with obesity. We know, for example, that maternal smoking causes decreased birth weight and increased obesity in adulthood. And we know that babies who are greatly overnourished or undernourished in the womb will tend to be obese adults who suffer from cardiovascular disease. All of these factors can, and arguably do, play a role in the millions of cases of obesity our society is dealing with. But what about chemicals that enter our bodies from the environment around us, or find their way into our system through the foods we eat or the water we drink? What role do they play? Can they disrupt the finely balanced hormonal systems that govern so many important functions in our bodies? If we look at the data, it is clear that there is a correlation between the increased use of industrial chemicals after World War II and the rise of obesity. However, it is very important to understand that correlation does not necessarily equal causation. For example, while chemical usage is rising and it correlates with obesity, many other things correlate with obesity. For example, global warming correlates with obesity, as does the increased number of SUVs on the road, although it is obvious that these things are unlikely to cause obesity. The main question we need to answer is, what actually causes obesity? We will explore that issue in greater detail during the rest of the lesson, but for now we do know this. Chemical usage affects the DNA of living organisms, and altering gene expression at key points in the life cycle of any creature can affect endocrine systems and the level of hormones they generate. So there could be a connection between chemical use in the modern world and the disruption of the endocrine systems in ways that result in obesity. Is that in fact true? In Module 2, that is precisely the question we will investigate.